Good morning. My name is Sergio Garcia. I'm from Telefonica. I'm in charge of the data and context chapter in FIWARE. And I'm going to talk to you about some of the pieces that we have in FIWARE for data and for context management. And later on, I will talk to you a little bit about what we are doing with smart cities with FIWARE. Okay. So the first generic enabler I want to talk about is one of the most important ones in the FIWARE architecture, is the context broker. Basically, this is a piece of software that is able to interconnect many others of the pieces of a typical FIWARE application. You will see an example later. So the context broker interacts with other systems, interacts with IoT data, as Carlos has explained. It interacts with event processors, it interacts with the big data generic enabler, and it also interacts, of course, with applications, web applications, mobile applications, etc. So let me give you some hints about what's the context broker and how it works. So basically, the context broker works over a simple and flexible data model, which is it consists of a context element, entity that can host or can have different context attributes. A context entity or an element can be any sensor, can be a person, could be a car or mobile phone, whatever. It can have some context data associated with it. On the other hand, we have attributes, the context attributes. That this can be whatever measure is gathered by the sensor, the location of a mobile phone, whatever. So basically, this is the kind of information that the context broker manages. Okay. So how does it work? Basically, it provides two sets of specifications. It's important for us NGSI 9 and NGSI 10. NGSI 9 offers several capacities to manage sources of context information. So you can notify if there's a new source, a new sensor, or you can subscribe and watch if something's happening, if there are new sensors of a given type, things like that. On the other hand, we have a number of operations in our specification for the management of the context information itself. So basically here we have operations for updating context information from different sensors. This is what we do, for instance, when we receive data from the sensors. And on the other hand, it's possible to subscribe under certain conditions to the changes in the context. For instance, you can receive context information whenever there's a change in some context entity, a new change in the location of a mobile phone, for instance, or you can receive periodical notifications of the changes of context. Of course, you can also query. The interesting thing of this context broker is it's a highly scalable and reliable piece of software. That means that it's really thought to be used with the Internet of Things scale of data, right? And this is a core element in our architecture. I would like to also talk a little bit about big data generic enabler. Well, as you know, it's basically based on a Hadoop map and reduce basis, and it also offers HDFS-based storage. And in order to use, well, you can use SQL-like APIs to access the data and to manage the data. We used in two different directions. We use it for analyzing big data that we have, but we also use it for the storage of open data from different, in this case, municipalities. So we publish all the data in our big data platform so that developers can make use of it, analyze, query, or whatever they want to do. So to give some examples, this is what you see here is an application based on some data that has been published by the by the municipality of Malaga about animal pests or plagues. So we are able to do some correlations, some analysis and predictions, and to show them on a map. We are also storing other kinds of informations or open data from the municipalities, information from sensors, historical data about bikes renting, air quality and pollution information. So all that data is being pushed to our big data platform for the usage of developers. Okay. So basically what you can do with the big data generic enabler is first, you can, of course, deploy your own cluster of Hadoop on top of the FIWARE cloud infrastructure. So automatically you will have your own cluster to use it. You can destroy it later. Of course, you can also use one of the global instances that we have running now with data from the different municipalities. So you can go there, use the data sets that we already have. You can upload your own data there, and you can even connect the information that is published from your IoT devices, the Raspberry Pis, for instance, and store all this data automatically in the big data platform. So basically, you can have all your data there and use it for the typical things you do with a big data platform. You can do your own map and reduce processes, of course. You can use Hive to make queries in SQL-like way. And you can define UCI workflows, so the typical things you do with a big data platform, okay? The interesting thing here is that it's fully integrated with the rest of the platform. So in this picture, I try to summarize how these components interact each other. So you can see here the context broker. You can see here the big data. And there's an additional component here, which is the complex event processing. It's another generic enabler that offers scalable functionality for processing events in real time and the correlation of events. So basically, this is the scenario that we show as an example of what can be done with the platform. We can receive NGSI data from sensors, from other systems, from devices, from wherever. This context information can be pushed to applications, to an application layer. It can be also be read or queried by the complex event processor to generate insights or additional actions based on the context information that is gathered. The complex event processing is itself able to generate new context information. For instance, it can generate alarms. And all the data is also stored in the big data platform that eventually can be used for feeding the context broker and also for providing additional information for the context, for the complex event processing. So that's more or less an idea of what we have about context and data management. There are many other generic enablers. This is just an overview. If you want additional information, I will be around so I can answer your questions. And now, I would like to shift to a slightly different issue, which is smart cities, and how we are using this functionality, this infrastructure, these possibilities for connecting smart cities. So Carlos has already elaborated about Internet of Things, about application platforms. I have elaborated a little bit about the data in context. Later on during the morning, you will have presentations about the cloud capabilities, the media management capabilities, virtual reality, and so on. Also about marketplace and store capabilities. So basically, I want to talk to you about what we are doing with the smart cities. So, well, this is something I read a couple of days ago. Oh, sorry. Currently, more than 50% of the world population live in urban areas. By 2050, it will be over 70% of the population. And today, the 20% of the global population in the world already live in the 20 biggest cities in the planet, okay? So this can give you an idea of the kind of challenge we are managing with, or we have to manage with the smart cities. In this moment, I would say from a technological, but also from a political point of view, the smart cities are gaining momentum. There are kind of different trends that are gaining momentum, and now we have, I would say, the breeding ground for the development of the smart cities. It's somehow a hype, it's true. It also has some risks, but there are a number of possibilities, very interesting possibilities. So the ingredients we have here are basically cloud technologies that allow developers to create or basically to outsource the management of the infrastructure. We have smartphones connected everywhere. We have geolocalization features. This is part of our lives already. We have all the Internet of Things capabilities. There are lots of sensors connecting every day to the Internet. I have already talked about the capability to manage large amounts of data, of information. Also from the public administration, there is a very important trend about open data and open government. And finally, and last but not least, we have the entrepreneurs and developers that are pushing and willing to make something interesting for improving the life of in the smart cities. So I think this is pretty much the momentum. We are working hard to have many proofs of concept, but in this very moment, while this is happening, it's also important to, let's say, to take this to real life, to create real applications for real cities in a scalable way, so to make it really practical, and this is already happening. So we have like 3 important aspects or tenets in a smart city. We have the services, public services from the municipalities, transportation, libraries, bikes, rental, whatever. We have also private services, power supply, commercial services. On the other hand, we have a lot of data. We have data from the public administrations, open data. We also have a lot of data coming from the citizens that are willing to participate and offering their data to the city. And finally, we also have very interesting infrastructures, Internet of Things, cloud infrastructure, communications. So all these 3 different aspects provide the ground for the smart city, but well, the smart city is nothing without the smart citizens and the smart developers. Developers willing to make interesting applications out of this data and this infrastructure. And on the other hand, the citizens that are willing to use those applications and to use the data in order to transform the way we live in the cities. But we need something in the middle. We need the glue. We think this glue can be FI-WARE, a platform that offers a number of possibilities for developers to create new applications. And that's what we are indeed pushing in this moment, right? How to use FI-WARE to leverage applications in smart cities. So when we connect smart cities to FI-WARE, basically we do it in 4 different ways or 4 different aspects. Okay, these are the most important ones. There could be others, but these are the most important ones, and this is basically what we are pushing with the cities. So first, I will start with the open data initiatives. There are now many municipalities offering open data. Usually with a portal like Seekan portal, but sometimes with specific portals in different ways, different interfaces and so on. We are pushing the cities to add all this information to FI-WARE so that it can be used by developers using the different generic enablers we have explained this morning. On the other hand, we have all the Internet of Things, the capacity to get data from sensors, from smart meters, and so on. We have the possibility to integrate vertical systems to get real-time data from other municipality services, getting real-time data in the context broker for public transportations, for instance. We can receive NGSI data from many other external systems. That's a great possibility also for the integration of smart cities. And finally, we have media. We are also experimenting with the connection to the video surveillance media streams with different generic enablers that we have in FIWARE. You will see Currento, for instance, later, and how they are using it for smart cities. So we have these 4 possibilities and many others, of course. And this is the kind of activities we are pushing with the cities. In this moment, there are quite a number of cities already connected to FILAB. Some others are in the process of joining to FILAB. We have activities with different Spanish cities, Malaga, Santander, and Sevilla. Maybe these are the more prominent in this very moment, but there are other joining, other cities, Valencia, Las Palmas, and some others. There are indeed cities all over Europe. We have Trento, we have Torino in Italy, we have Spo in Finland, we have Lisbon with their city SDK platform and some other platforms. So as you can see, there are a bunch of cities connecting their data, connecting their systems, and making interesting applications. So I can go quickly through some of them, but if you want more details, just feel free to ask me later. For instance, in Sevilla, they are working in a specific tool for connecting sensors that are getting some information about the healthiness of water in the ornamental fountains, so that they can know the healthiness of the fountains themselves and have a dashboard and so on. So that's a possibility. They are also doing interesting thing with video surveillance cameras to detect masses of people moving around the city. This is an important security issue, especially in Easter. So they are just getting the video, analyzing the video, and to detect if there are too many people moving around, fast or slow, whatever. So in Malaga, for instance, they are building an application for getting the data from sensors in the smartphones of the citizens. Well, I mean, of course, Santander, they have thousands, and I say thousands of sensors all over the city that are being integrated into FIWARE and can be used by developers. So there are lots of activities around this issue. And now, I would like to make a small shift and to show a little bit one proof of concept, one demo application that we have built on top of some open data from Smart Santander and using many of the generic enablers that we have in FIWARE. So this is basically an application that can manage the workforce for the management of street lights in Santander city center. So we have some sensors in the street lamps in a specific area of the city. We have some bands moving, and we're collecting information from those sensors, generating some alarms whenever something strange happens. We can send technicians to the specific places where the issue has been reported, and so on. So I have just added here some tags explaining how the different generic enablers in FIWARE are being used in this application. So, for instance, we have the IoT generic enablers that are gathering information from the sensors in the city. We have the location generic enabler that it's gathering information about the location, the position of different technician spans around the city. We have the cloud object storage that we can use to store pictures submitted by technicians of citizens about problems in the city. We have the context broker that indeed is aggregating all the information from the different sensors and also gathering information about issues or alarms. We have the complex event processing that is analyzing the stream of data from the different sensors and triggering issues whenever something strange happens. And finally, we have the worker platform, but indeed it's all you see in the screen. It's the web platform that we use to build web applications and mashups. Okay. So we also have historical data, and we store this historical data in the big data platform so that it can be used later on for further analysis. Okay, and that's basically it. I can show you the architecture so that you can have a more technical idea of what's behind this application. So you see here the sensors, you see the IoT infrastructure, you see the context broker in the middle distributing and publishing information all over the architecture. The context broker receives information about the sensors, of course, receive information from the location generic enabler about the position of the technicians. It also interacts with the complex event processing to send information from the sensors, but also to receive information from the different tissues. And we have the FIWARE cloud platform where the application is indeed running. The object storage capacity, as I said, is used to store pictures for the application. So that's basically the application. Before moving on, I will, of the application, well, the issue is that I only have one hand, but I'll do my best. So this is the application running, okay? You can see here the different sensors, the information from the sensors. You can click on it and see the different measurements that we have. We can see also the vans moving around the city. Of course, this is simulated. This is not, we don't have in this very moment real data from real vans in the city. But the information that you can see here in the sensors is real data that we are indeed gathering in this very moment from the sensors in Santander City. So the complex event processing is in charge of receiving that information and generating warnings or issues so that we can assign a technician to solve the problem. Okay, so we have a number of technicians in the different bands, and we can assign a different, a specific technician, and to manage in this way the workforce of the technicians. There's also a possibility here. It's interesting. You see here this picture. The technician can go with his smartphone to the around the city. If he finds a problem, he can take a picture and generate a specific issue on a given street light, for instance. So this is a picture that I took a moment ago from my mobile. We could even do the same experiment. So you can report an issue, upload your picture from the mobile phone, and then here in the dashboard you will see what the technician is sending. So basically this gives you an idea of what's the application, what can be done indeed with FI-WARE for the smart cities. The interesting thing of this application is that it was very easy to develop it, and it was done in a really short period of time, but by a couple of developers. So the interesting thing is that you already have a number of pieces there available for you. You can go, pick the data, get the generic enablers you want to use, and start developing. It's really fast and to develop something like this. So if you are interested, I can give you a step-by-step demo then there in the different screens. So some more ideas about what's going on here. We can see the historical data from different sensors. We click here, and we can see the different values that have been measured by the sensor in the last period of time. You can select how long, for instance. So this is the kind of things that you can do with FI-WARE. And that's it basically from my side. Now I would give the floor to my colleague Fernando to speak about cloud computing, right? Yes? So if you have any question, you want to see the demo step by step, you want to see in detail what's this application about, just go to the desk and I will answer your questions.